I had a viewer reach out to me and ask about how to make something that would look like a rocket fin in FreeCAD and have it curved in a way that it would be an airfoil, so it could provide lift but be in the shape of a rocket fin. So he or she, I'm not sure who, gave me this version 1 picture, and that's kind of what they wanted to emulate. And as I got more and more into this, I realized this is serious business. It is very difficult to surface something that would be an airfoil and follow this profile in all dimensions correctly and still maintain the integrity that you need for a foil. And given that airfoils have never been really my specialty, I've never gone in depth with them. But how do I maintain a constant foil? You know, if I were to create an airfoil surface and cut the surface out with this general similar sketch that I made in FreeCAD, then you know, you lose the curvature that you need to have integrity as a foil. So the surfacing was quite challenging to maintain a complex shape like this and still be able to do a foil. But I want to show you the way that I was able to recreate this where at least had integrity as a foil. You can see I sketched out a little boundary, and then I made one version of a foil. Notice it's a little bit blocky, but it has the foil shape and it fits within that boundary pretty good. It's especially blocky right here, and so I have kind of a smoother, swoopier version to play with. Again, both of these are actually pretty easy to make, but to do it with surfaces and get the surfaces, whether it be a lofted surface or a ruled surface or anything, it would be very, very challenging. I tried and I failed. So if anyone has a way of doing this with surfaces that you can maintain a really good profile, that when you cut the surface to shape, it still has a consistent profile going down, I would love to know. So let's get started on making some of these fins and my methods for doing it. The first thing I'm going to do is create a new part, and I'm going to go to the sketcher, and we'll be working off the part workbench and part design as well. So we're going to go on the XY plane, and I'm going to sketch out kind of a general shape that I'm looking for. So we're looking down on top of our rocket fin slash wing slash airfoil slash whatever you want it to be. I'll use a rim point arc and create a line. Use the T key to establish a tangent relation, the A key for an angle, make that 60 degrees, but I typed 30, 60 degrees, and I'm going to come out here, again T for tangent. I'll make these equal, E for equal. Might as well Shift R, and you can make this whatever size you want because you can always scale it with Reynolds number. So I'll go with a value of say 0.75, but that didn't work. Shift R for radius. Well, that's a little better at least. We can make this horizontal with H if we want it to end on horizontal. And we definitely want these endpoints to be horizontal, so H. We'll have this go down. Again, sketching out a general profile. Excellent. We'll come over here. I'll use another arc. T for tangent. E for equal. So that's kind of a general outline of the rocket fin we're looking for. Again, T for tangent, E for equal. The next thing that I want to do, and this is probably too small, so I'll give it its own radius. 3-inch radius is a bit more acceptable, and I'll use parallel. Might as well fully constrain this while I'm here. Shift H. Say this is 12 inches. Shift V. 6 inches. Looks like my last degree of freedom. I have a tangent there. So vertical dimension, we'll say that this comes back about 3.75 inches. So we've got a basic outline of the wing. Now the next thing I want to do is break this sketch up a little bit. I'm going to make this into a construction line. Now notice I've got a point right here. I want to pay attention to this point. I want to make a polyline. Right there. Now I'm going to use the V for vertical key. Vertical. Right, so now I've got a point here, and I have a corresponding point on this downward profile. This marks at, say, this is the x-axis. On the x-axis, this is a corresponding point to the top and bottom. That's what we want throughout. Now I've got a point here, so I'm going to put a point on my top line. For construction. And I've got another point here, so I'm going to make another line. The trick is, every time I see a point, I'll put a corresponding point and make it vertical. 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 Oh, there, vertical. And make this for construction. Polyline. What is FreeCAD doing? Let me try it one more time. There we go. Alright. Vertical. It looks like I'm over constrained, so Control Z. What do we got here? I have to merge these points. I guess that was it, so I'll go vertical. Boom. Alright, so I got a point here, point here, point here, point here, point here, point here, 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 here. So with every point I have on the top profile, I've got a corresponding point on the bottom profile, and they are vertical. The better definition that you want, put more points here, especially along curves. It really wouldn't hurt if you wanted to have a really high definition wing to put 1 or 2 points on every arc. I'm not going to go to that level of granularity because that will take way too much time and I will completely bore you. Now that I've got this base sketch done, I'm going to highlight the sketch and go into Part Design and create a body. And in the history tree you can see, because the sketch was highlighted, it's now assimilated in my body in Part Design. So, first thing I want to do is highlight. So the first thing I want to do is highlight my YZ plane. And with that plane highlighted, but I create another body, Control Z. I want to go into my origin, highlight my XZ plane, and create a datum plane with reference to that. Fix my view if it's possible, and then go to the second set of points that I've highlighted, and boom, I've already got my XZ plane on this line, so this is the next point over. Okay, XZ plane. Put a plane on my next set of points. Okay. XZ plane. Put a plane on my next set of points. Oh, but I highlighted the line, so XZ plane point. XZ plane. Oh, but I again highlighted the plane, so XZ plane right there. XZ plane there. Okay, so we've created a bunch of datum planes. I'm going to temporarily hide them for now. Let's go to the XZ plane and create a sketch. So you can see there's my profile. First thing I want to do is I've got one edge right here on the origin. We're going to go to Edge Import. Highlight this edge. Getting normal now. I'm going to sketch out a little airfoil. We're going to take the imported edge and make it coincident, making sure that I'm doing this properly. Looks like I am. Make that coincident. And we're going to make this vertical. Right, so now we've got a nice little arc. Next thing I want to do, take a straight line, draw it from one endpoint to the origin, T for tangent, highlight both of these. Next thing I want to do, maybe Shift R to give this a radius, let's say 0.25. Again, airfoil design isn't really my forte, but we're going to get through this. H. I'm going to put an arc on this side. T for tangent. And we have 1 degree of freedom. So give that a 30-inch radius. Now we'll close, and if I open up my first datum plane, that highlighted, I'll create a sketch. And let's hide sketch 001 so it doesn't get in the way. And I want to edge import an edge here. So there's the next edge that I had on the vertical constraint. You're going to get coincident, straight line on one side, T for tangent, Shift R for radius, 0.25, H for horizontal. We're going to do a vertical relationship between these. And let's do a 3-point arc. Tangent, Shift R, let's do something like a 30-inch. Alright, so with that sketch being done, close, highlight the next datum plane. I'm going to sketch on that datum, and I will hide the next sketch. There it is. import the corresponding point. We'll go coincident and vertical with the V key. Straight line. Arc. The arc will be tangent. Shift R for radius. How about, it's getting smaller, 0.2 inches. Tangent. Shift R. How about something like 25 inches? Or 27 or 30. 30 is not bad. Tasks close. That should be our next datum plane. So sketch on that. I did not want to do that. That's better. Alright, yeah, so we're going to import the next point. As you can see, we're making a series of profiles. Coincident, straight line, T for tangent, T for tangent, Shift R, 0.25, V for vertical. And we're left with this, so Shift R, maybe something like 30 again. And let's close. You can hide this sketch. And yep, that's our next one. So datum plane highlighted. Importing our next point there. Coincident, Shift R, go with something like 0.125 since we're getting to be a small profile. Let's go with an arc, tangent. I better merge these 2 points. V for vertical, straight line. Get rid of that vertical auto constraint. Tangent, Shift R, and I'll go with 30 again. Well, we're getting small. 25 maybe? Alright, 25. Tasks close. And we're almost to the end. Datum plane 4, hide the sketch. Import the last point. Normal to the sketch. Coincident. vertical arc, tangent, tangent, Shift R, 0.125, Shift R, 30, or 25 last time, 20. Okay, close. So now I've got my series of sketches. On one of the sketches up here, I somehow got away with not giving that a radius, but it should work just fine. So next thing I want to do, I'll save. Let's create a loft. Let's cancel. Make sure I have my correct sketch highlighted. So starting here, loft, add section here, add section here, add section here, add section here, add section here. As you can see, that turned out pretty blocky. There are some problems fitting that in, but you have an airfoil in the shape of a rocket fin. Of course, the idea is if you can add more profiles where you're going off, it'll be far more accurate. But of course, adding more profiles would simply make the video more boring. But the moral of the story is, especially around curves, add points to the top and bottom that have the vertical constraint like we've done, and that will smooth that wing out. Another method, let me delete this loft, and I'm going to show my sketches. I think this is a better result, even though it's a little bit blocky. Loft from here, add section to here. Okay. And then we go to the bottom of the loft, sketch 1 with highlighted loft, add section, next sketch. Okay. Oh, I've done the wrong sketch though. Sketch 2 is what I wanted. Loft, add section here. That fits into the boundary so much better. Additive loft, sketch 3, loft, add section here. Sketch 4, loft, add section here. Okay. Sketch 5, loft, add section, and to our last one. Okay. I think it's more of a realistic looking wing. And if I bring this up, I sketched this to different proportions. However, the fin really doesn't look that much different. So hopefully this was helpful in your endeavors to create some profiles that are airfoils in FreeCAD. Just remember, if you don't want to do a whole lot of profiles, this blocky way of doing it is not really that bad of a way of doing it. If you do want to have curves and radii, make sure you have a lot of profiles, especially around radiuses in your overall boundary, because that will smooth it out. It will make something like this a lot more precise to fit within the boundary that's been set for it. So again, if this is helpful, please subscribe, and I'll see you in the next video.